Till now, we have looked at the idea of distance, displacement, speed, and velocity. Now, we're looking at a scenario wherein speed or the velocity is changing. That is, the object is accelerating. Please note that acceleration is not about how much faster we are going. It's not just about going faster. It is also about how fast you are getting faster or slower or changing the direction. I'll give an example. Consider this. Consider that scenario. So what's happening over here? So we have an object, say an object. It is over here. And after a second or two, in t seconds, it's moving with that velocity. Right? So it was at 10 meter per second and went to 50 meter per second. There's one more object. It's actually pretty fast. And after the same time interval, right, after t seconds, both are of same time interval. So if this is 0 second, this is t second. If this is 0 second, this is t second. Later, the velocity changed from 20 meter per second to 145 meter per second. According to you, is case 1 the scenario wherein it has a larger acceleration, or case 2? Here, the change in velocity is represented with delta v is 40 meter per second. Here the change in velocity is 25 meter per second, even though this has a huge set of numbers, but the change is 25. Since the time frame is the same, we can tell that conclusion, case 1 has larger acceleration. Did you guys understand what is acceleration? How much is changing? It can be either an increase or decrease. It doesn't matter. Again, it can be an increase or decrease. The amount of change is what is important. Got it? Now, as a definition, acceleration occurs when the velocity of the particle changes over time. So with that as the definition, can you guys answer this particular question? So again, acceleration is what? Change in velocity. So with that in mind, can you answer this? Which of the following is or are getting accelerated? An object increasing its speed? Yes, this is acceleration. Why? There is increase in speed. An object decreasing in speed? This too is an example of acceleration. The word decrease means what? There is change in speed basically. So there is change in speed. Next, an object altering its direction? Yes, velocity is not only has the speed kind of aspect, that is the magnitude, but also the directional aspect. An object increasing in speed and altering its direction. Yes, we have both the things happening. So this too is an example of change in acceleration. So whenever you see any change with respect to direction and speed, right, we set to have an accelerated scenario. So I'll show you one example. So this example is an object moving in. Yes. Do you think there is an acceleration happening over here? Is the object accelerating? No. Can you tell why no? Because it's moving at the same speed and the same direction. Well, what about this? Yes, there is change in speed, not the direction, but change in speed. So this too is an example of accelerated motion. Now let me go with, I think this, I guess. Okay, no, I can't show this now. We'll come back to that. SI unit of acceleration is, so let me show you guys how to figure out accelerations SI unit. So acceleration, I have not yet come to the formula, but we know that it's change in velocity by time. Okay, we know the definition as of now. So we know that SI unit of velocity is meter per second and SI unit of time is second. And so we are looking at meter per second divided with second. This will be meter per second square. Okay, I hope you guys are good with your math. So this is nothing but into 1 by second. And that's how you get this. Right, that's the SI unit and the dimension. Dimension of acceleration. So acceleration is given by change in velocity by time. So dimension of acceleration is equal to dimension of velocity by dimension of time. This is nothing but LT minus 1 divided by T. And so this simplifies to LT minus 2. Okay. And oh yeah, I didn't write it in standard form. You guys know how to write it, right? So that would be M0 L1 T minus 2. Now, motion diagram of an object accelerating. Okay, so there are many forms. So I'll show you guys one of it. Let me check one thing. Okay, so it's accelerating. So I'll show you guys. So this is at a constant acceleration. So you can see the distance the turtle is covering every second, it's changing. That means what? Its velocity has to be increasing. So the turtle is moving with accelerated motion. Now the next stretch, bit of it, whatever you will see, it will not have accelerated. As the distance that it covers per second will remain the same. So velocity is constant over here. Let us discuss this, So motion diagram. That's the name, motion diagram. Yeah. So every second, it's a snapshot. Snapshot of motion of an object every second. Every second, and this leads to this. So clearly the distance over here, it is increasing, while over here, my says that, can you see that? The last stretch, the distance that it's covered is constant. So you can see the graph now. The acceleration, can you see that it dropped down to 0? Till the last minute, it was accelerating. That is the distance it was covering. It kept on increasing, then it dropped. Can you see the velocity also? Can you match them? Till the 7th second. Right, I can do that for you guys. Till the 7th second, the velocity was increasing, then it became constant. And here you can see the same corresponding time frame. Can you see that? Till the 7th second, there was acceleration and then it dropped. Right? So same thing can be with retardation also. That is, the object can slow down. So for that, we have brakes. Okay. So I'll put brakes, or let me fast forward and then I'll put brakes. Oh wait, no. Something is wrong. It's accelerating more actually. So I wanted it to. Hmm. Okay, is there something wrong with the code? No, it is actually. But why is it moving forward? Velocity is dropping apparently, but I couldn't notice that. But as per this, yeah, sorry, you are not able to see that. As per this, it's dropping, supposed to be dropping. So we couldn't get to see that, but yeah, it was happening. So that is your photo diagram that we can use it in different scenarios to understand quite a few things. So acceleration. We understood that object can move, right? So till now we understood that object can move. And how do you determine something is moving? With the help of, right, a dot or a point or a frame. And what I'm talking about is your reference point or frame. Now, with that in mind, we'll be able to talk about displacement and distance. So displacement, distance are your scalar and vector quantity. Corresponding to this, you have speed and velocity. Since all of this are vector quantity, we have magnitude and direction. This deals only with magnitude. So whenever we see any change over here, the object is said to have accelerated. Now, in the next set of videos, we'll look at when do we have a positive acceleration, when do we have a negative acceleration, and case by case, we'll get to see that. We saw that with velocity, since it has direction and all of that. So we saw case of positive and negative velocities, right? While distance can be a 0 or more than 0, but not never. It cannot be less than 0. Displacement can be 0, greater than 0, or less than 0. Right? Okay, so now it's time for you guys to copy things which you feel is important and make sense to you so that you can revise. Oh yeah, by the way, that corresponding to the first slide. Second slide. And corresponding writing material is over here. The dimension as well. So using motion diagram, we'll be able to learn a lot. I use it. I frequently use it. So I have it as a separate slide. And if you guys want to, have a picture like this, you can.